Find inflection points and where the graph is concave up and concave down. All right, before I do anything, let me remind you or let me teach you what's what. Inflection points are when what your x values are when your second derivative equals 0. Concave up on a graph is when you have parts of your graph curling up like that. That happens when your derivative is positive. Concave down, very similar, looks like this. That happens when your derivative is negative. So what I'm going to do is I'm going to take the second derivative, find my x values when my second derivative is equal to 0, and make a sign chart. So those of you who are obsessed with my YouTube, if you've seen my video on inflection points and increasing and decreasing functions, this is extremely similar, but we take it an extra step by taking the second derivative instead of the first derivative. All right, so first derivative, first things first, is going to have me bring down that 4, make it x cubed. Bring down that 3, make it x squared. Bring down that 2, multiply it to negative 3, giving me negative 6, x to the first, and you become 0. So that's first derivative. Second derivative is going to turn that 4 into a 12, 12x squared. Turn that into a 6. So we got 6x minus 6. Now set that equal to 0 and factor. I'm going to factor out a 6, which gives me 2x squared plus 1 minus 1. I should be able to factor that out. So, I mean, one of them's got to be positive and negative. One of them's got to be 1. One of them's got to be x, and one of them has to have a 2 in front of it. So if it's going to be negative, I'd imagine this is the 2, because you have 2x times negative 1. 2x squared, then 2x times negative 1, which is negative 2x. So I had it backwards. Let's move the 2 over here. Look at that. So x squared, 2x squared, minus x plus 2x minus 1. So that's what I need. All right, zero product property says that when you have factors multiplying to be equal to 0, you set each one equal to 0. Nothing happens here. If I have x plus 1 equals 0, then one of my inflection points is going to be negative 1 if I subtract 1 from both sides. If I take 2x minus 1, set that equal to 0, since I'm running out of space, add 1, divide by 2, my other inflection is going to be a half. Inflection point is going to be a half. So my inflection points, all 2 of them, are negative 1 and 1/2. I'm going to take that information and I'm going to make myself a sign chart. All right, I'm going to use the fact that I have negative 1 and a half, and I'm going to find the intervals. So what's going on between negative infinity to negative 1? What's going on between negative 1 and a half? What's going on between a half and regular infinity? And I'm going to pick numbers in these 3 intervals, plug it into my second derivative, and see if I get a positive for concave up or a negative for concave down. So let's just pick the easiest numbers we can. I'll pick negative 10 for this guy. Let me move that down here. Will it make me do it now one by one? So let's do negative 10. Let's do 0. And let's do 1. So y double prime of negative 10 is going to be 12 times negative 10 squared plus 6 times negative 10 minus 6. Okay, let's do a little bit of mental math. Negative 10 squared is 100. 100 times 12 is 1200. 1200 minus 60 is still really big. Minus 6 is still really big. So we get a positive number here. So this is positive, meaning from negative infinity to negative 1, concave up. Okay, let's plug in 0 into our second derivative. 12 times 0 squared, I think I can handle that. Plus 6 times 0, I think I can handle that. Minus 6 is going to be 0 plus 0 minus 6, negative. So you're concave down. And let's see what happens when we plug in 1 to our second derivative. 12 times 1 squared plus 6 times 1 minus 6. 1 squared is 1. 12 times it is 12. 12 plus 6 minus 6 is still 12. Positive, positive. Now what this means is inflection points tell me where it's neither concave up nor concave down. That's the switch between concave up and concave down. Okay, that's what inflection points give me. This is the change. So what I know from this information is my graph is concave up on the intervals connecting negative infinity and negative 1, but not including negative 1 because it's 0 there. It's neither. And from a half to positive infinity. It's concave down in the interval where my second derivative was negative, and that happened between negative 1 and a half. So, like I said, very, very, very similar to critical points and increasing and decreasing. You just had to take this one step further. So in the end, a lot of work. Really not that bad, though. I like it.